So this lab is going to be about waves. It's a hands-on lab, and today we're going to be demonstrating mechanical waves, and that type of wave does require a medium. However, the other kind of wave is an electromagnetic wave, and that does not require a medium like light. This lab is going to show how energy can be transferred through different means, whether it's through like colliding objects or through waves traveling through water. So for the first part, we're going to show how energy is transferred through a train of marbles. So we're going to put several marbles in a groove on this track. So we have 5 marbles there. And what we're going to do is we're first going to slide one marble down the track. When I do so, the one marble on the end bounces off like that. Now I'm going to slide 2 marbles down the track. When I do so, the 2 marbles at the very end are the ones that fall off. And finally, when I transfer 3 marbles down the track, the last 3 marbles on the track are the ones that are pushed off. And this is because that when the marbles collide, the energy is transferred through them, which pushes the marble off the end, and the starting energy that transfers through and pushes the marbles off the end corresponds to how many are pushed off the end. So if I push one marble down, one will be pushed off. So some of the energy is transferred through, and some of the energy is also lost, mostly due to the friction when the marbles slide down the track. And this is an example of a pulse wave because it's just one single disturbance every time that I hit the marbles. And the next part that I'm going to demonstrate is a transverse mechanical wave by moving this rope. If you move it left and right like this, you can see that it creates a wave motion. If I do it just the one time, it's a pulse wave because it's a single disturbance. But if I do it in multiple times continuously, it's a train wave. It's because it happens continuously, like I said. So that is also a transverse mechanical wave. And now the next part I'm going to demonstrate is when waves, energy travels through water as waves. And so to do this, we have a shallow pan of water. And for the first part, I'm going to fill up this dropper with water. And we're going to demonstrate another type of transverse mechanical wave. When I drop one drop in the middle of the pan like that, you can see that the energy moves outward and then reflects off of the flexible boundary of the edge of the pan, and you can see the wave move back in towards the center. I'm going to do the same thing except drop it near the edge of the pan this time. And when I do so, you immediately see it bounce off the edge it's closest to, and the wave also moves around the outside of the pan like that. So when it's dropped in the center, like I said, it ripples out in circles, and then when dropped near the edge, reflected off the edge of the pan. And it is a flexible boundary, so the wave is erect. And if the wave were to move through a different material or a different medium, like if it went from water to a thicker substance or anything like that, it would change its speed and be refracted. However, since we're just dealing with water, there's no refraction. Now the next part I'm going to demonstrate is another type of transverse mechanical wave, and I'm going to drop a small stone into the pot of water. When I do so, I see the same pattern of the energy being transferred out through the waves and then reflecting and coming back in, but I did see it happen more times than when it was just the drop from the dropper alone. I'm going to do the same thing with a penny, and so I'm going to drop that in, and when I did that, I saw the same pattern here again because it is also a transverse mechanical wave, and it went out and back in similarly to both the small pebble and the drop of water. So these were all transverse mechanical waves, and it was the same pattern, but the amplitude of the waves changed based on the mass of the object. So the heavier the object, like the heavier stone, which is obviously heavier than the penny and the single drop of water, had a greater amplitude, so the waves were bigger and it reflected back off of the wall more times. So in order for energy to travel through a medium, the medium must possess some sort of amplitude, velocity, frequency, and period. And then your 2 different types of waves are transverse and longitudinal. The ones we've demonstrated here today have been transverse, in which the medium vibrates perpendicular to the direction of the wave, so that's perpendicular. And then the other type is a longitudinal wave, which travels they vibrate parallel like this. So overall, what we saw today was that the lab demonstrated how energy is transferred, whether it's through objects colliding with each other like the marbles, or whether it's through energy moving through water in the form of waves.